Okay, this is Module 1, Lesson 5, Question 2. So, what we want to do is take this graphing story, and we're going to start by annotating our text. So, suppose two cars are traveling north along a road. Car 1 travels at a constant speed of 50 miles per hour for 2 hours. I want to go ahead and highlight the pertinent information. So, 50 miles an hour for 2 hours. Then it speeds up and drives 100 miles an hour for the next hour. Now it breaks down and has to stop. So definitely want to point out the fact we're stopping, and he has to work on it for 2 hours. So for 2 hours, it does nothing. When he gets it running again, he drives at a constant speed of 100 miles per hour. Now, that's what car 1 does. So we can go back and look at that information to figure out what's happening. So now when we talk about car 2, this one's really simple. New information, it starts 100 miles in front of car 1. So they don't start at the same place. And what's really cool about car 2 is it travels at a speed of 25 miles per hour throughout the trip. So it has a constant rate of change of 25 miles per hour. So now we can go to the table, use this information, and fill in what we know. So I want to start with car 2 because this one is really straightforward. It started 100 miles in front of car 1. So our distance is already 100 miles down the road from where car 1 started. It's going 25 miles an hour. So every hour it's increasing 25. So 125, another 25 gets us 150. And be careful here because when we go to 2 to 4 hours, we're increasing 25 each hour. So we go to 200. And then we increase 2 more hours from 4 hours to 6. So 25 plus 25 gets us to 250. And that's the path for car 2. Now, when we go to car 1, remember it started, it hadn't gone anywhere in the beginning. The first 2 hours at 50 miles an hour travels 100 miles over the course of 2 hours. Now, next, for another hour, it goes 100 miles just in that hour. So its total distance is 200 miles. But from 3 to 5, in that 2 hour time period, if you remember, the car was broken down, didn't go anywhere. So you're still at 200 miles from where they started because they didn't do anything. And then the last hour, he went another 100 miles. And that's how we complete our table. So now we're going to use this data to plot this information on the coordinate plane. So again, I want to start with car 2 because we know that it started at 100. And every hour it's going an extra 25 miles. So the first hour it's at 125. So this is 1 hour, and 125 is halfway to 150. After 2 hours, we're at 200. Actually, we're at 150, aren't we? Because it's 25 miles an hour. So 125, then 150. At 4 hours, we make it to 200. So 1, 2, 3, 4, 100, 200. And at 6 hours, we're at 250. So 6 and up to 250. And what I really like about this is that's a linear function, so I can connect all my data points with a line. So car one's not so user friendly. It starts at 0, that's easy. So 0, 0, the origin, that's the beginning. And for 2 hours, it's going 50 miles an hour. So 50 miles for the first hour, 50 miles for the second hour. We're at the point to 100. Then for the next hour, it's going 100 miles an hour. So at 3 hours, we jump to 200. And it stays at 200 for 2 hours because it broke down. So here we're at 200 again. Now from hour 5 to hour 6, it goes another 100 miles an hour. So we jump like so. And notice we are going to use lines to connect the dots, but lines as in plural, there's going to be more than one line because this is not a linear function. He keeps changing his speed, so we have to adjust accordingly. So here's our line for the first leg of his trip. 2 hours, he traveled the first 100 miles. In the second leg, he traveled that 100 miles in an hour. The third leg, he sat still for 2 hours. The final leg, another 100 miles in that hour. So once we have our dots connected, this is, of course, car one. We can look at both graphs and answer the questions that go with it. So, the first point of intersection and approximate time for this. So what I want to do is just go over on my x-axis until I find that first intersection. And that first intersection looks to be somewhere approximately 2.5 hours. So we'll say 2.5, and it looks like more than a half. So I'm going to say 2.57. Because again, this is approximate. It doesn't have to be exact. And what is our distance at that point? It's more than 150 miles, but it's nowhere near 200. So let's say 160 miles. And then the next time that they meet is over here. Now, this one, our approximate is really good because at 4 hours, we are at 200 miles. And that's great for both of them. So that's a lot more precise because that's a lattice point. Now, when we come to the last one, we know it's more than 5 hours, but nowhere near 6 hours. So I would say that's 5.35. That's our x coordinate. And when we look at the y coordinate, we're not at 250 miles yet, but we're getting closer. So maybe 235 miles. And that's how we model our function to see the difference between traveling at 25 miles an hour continuously to the other car that's speeding and going slower. And that's where they meet. That's question number 2.